So, hi everyone. My name is Francisco. It's a great pleasure to be presenting once again some of the work that we've been putting through in the past year. Today I'm going to show you how to perform some hyperscanning measurements. We'll initially just talk a bit of what actually entitles hyperscanning, what kind of applications there are currently, and which are the fields of study which may benefit for this kind of experiments. What is hyperscanning actually? So what you're seeing on the screen is a photo from one of the experiments that were performed in the UK. We have several users playing music at the same time, and we were acquiring EEG. The lab was acquiring EEG and also trying to transform this kind of brain activity modulation into music that is playing according to their actions. So hyperscanning itself, it's a simultaneous recording of two or more subjects, which can be interacting or performing the same task. It will always depend on the kind of applications that you will be facing. So typically these kinds of applications can go more into the educational part where, for example, studies want to see how students are performing together when they are being taught something. You can go more into the entertainment part where we had, for example, Dolby Studios using some of our systems to see how their sound systems are performing, while people that were watching films were having EEG caps on the head, also with sensors, so you can always add other kind of biosignal. And that will give companies or entertainment enterprises the idea of what actually is going on with the audience, which is very, very useful and would be impossible without doing this kind of applications. You also have the case of healthcare and marketing, where you want to know what is the reaction of the people to a kind of product, etc. So the kind of applications typically are comprised of multiple subjects with EEG caps on the head, who typically are performing the same kind of task. This is something that we will be seeing here today, and this is something that is very common in this kind of applications. Then there is the BCI applications with hyperscanning, where the BCI is mostly used to enhance accuracy on the BCI. People are performing the same task, and by using their brain activity together, we can do an average, and if some users are not as good as others, we can have as a whole better performance of the tasks. And then you can also have social interaction studies studying how people synchronize their brains doing or performing a particular task, or for example, the interaction between a mother and the son or the daughter, or for example, a couple of a married couple, or even twins, or a team that is working together to solve an issue. So these are the kinds of applications which you'll be able to see. Hyperscanning has been something that has caused a lot of interest in study. We can see this paper from 1965, so a long, long time ago, where the people were interested to know how identical twins were synchronizing their EEG, and the result was that, for example, when one closes the eye, the other twin will have synchronization, so we will also detect alpha activity on the second person. While if you compare, for example, one of the twins with a third person, you will not see this replication of the EEG on their brain activity. So very interesting job done many, many, many years ago. So what do you want to have, and what do you need to have a good setup? Obviously, you want to have one or several devices. Most of the times we will need more than one device. You will need to have caps. You will have to have subjects possibly sitting next to each other in the audience, and looking, for example, at a projected wall where they will be able to see the tasks that they need to perform. You will be connecting these kinds of systems into a hyperscanning PC or several one, depending on your setup, which will then perform all the calculations and give feedback possibly to the subjects who are performing this kind of study. So one of the examples, as you can see here, a GUSP amp was performed by Babylon in 2016. This study is related to two pilots on an airplane simulator. The main goal was to check if there would be synchrony between the brain activity of the main pilot and the first officer. From the takeoff to the cruise altitude, then there happens an electrical fault and they have to solve this issue and land on another airport. And during all this time, they were measuring brain activity. So you can see that during the takeoff, you will see some synchrony between the users, meaning that they are performing the typical checklist tasks that they have to perform for the takeoff, and the brain activity is looking pretty similar. On the cruise, on the other side, you see the synchrony a bit more reduced because they are in a relaxing state. They are not concentrating on the exactly same task, and that indicates that the synchrony is not that visible as you've seen before, for example, on the takeoff. And then what happens? There happens a failure and they have to solve the issue. One has to take most of the controls, but they have to work together to perform this task. And then you see again, very, very strong activation synchrony between the two users. So this is an application which was highly successful at detecting how the brain activity is looking like from the takeoff to the cruise and the landing. So you can see during the cruise, synchrony is not as visible as on the takeoff and on the landing of the airplane. As I mentioned, you can also use hyperscanning on applications such as brain-computer interfaces. I will not introduce the concept as you have been hearing a lot of it during the spring school. But I will show you something that we did back in 2013. We had a small project inside the company where we questioned ourselves if people could actually work together and improve the accuracy and the speed of a BCI system. So what we did was taking 8 subjects, 1 female and 7 male. We will have more female subjects this experiment today. So that's very, very positive. They participated in a P300 experiment, which they were grouped in a room and seated in front of a projection wall. And you can see that they all had the typical 8-channel montage looking at the screen with Intendix, showing the characters which they would have to select together. So we were using the typical montage for P300s, so most of the electrodes placed on the visual cortex. Recording with sampling rate of 256, so we're using a couple of GUSP amps with some bandpass filter between 0 to 30 Hertz. They were trained in 9 letters, and then we hoped that they were able to actually wish a Merry Christmas to all our customers. So this is how the Intendix would work like. You have a speller, which you will have rows and columns popping up, and people can concentrate on a particular character that they want to select, and the system will be able to detect by making an average of all the triggers. So you can see there is the target and the non-target. So the target would be the letter that the subjects want to select, which the classification will find the positive peak after 300 milliseconds. Especially comparing to all the other characters where you have the EEG results close to baseline 0, the system is able to correctly discern between which of the characters the subjects want to select. So here is the video. I have to remove the laser pointer. The video, as you can see, you will see younger versions of many people of the company. For example, Christoph, looking very nicely and explaining how the system, what they are going to do. So you can see 8 people looking with a projector to the wall with one goal, which was spelling Merry Christmas. So we were using, in this case, 4 USB amps, so 8 channels per USB amp, and people were trying to select together all the same characters, so they knew which characters they wanted to select because they wanted to write Merry Xmas. And this was a very successful experiment that we did. So you can see that even for brain-computer interfaces, hyperscanning can be a very nice solution. And if you are interested in these kinds of applications for your studies, I truly recommend it. It's adventurous, but the results are really, really nice, and you can have really nice publications with these kinds of applications. So you can see they correctly selected Merry Christmas, but we are in spring, so this is from the past, and you can see here the difference between subjects, where we have the best single subject with an accuracy already reaching 100% in 3 flashes and pretty constant on 100% after 5. The worst single subject on the right side had difficulties reached around 98, which is pretty good anyways. But if you then join all the EEG together with this hyperscanning, you will have very nice results. So you will have 100% accuracy rate after 2 flashes, which is fantastic, I would say. So we also did the similar experiment last spring school. So some of the subjects will also be here today, where Angela and Slobodan were presenting some kind of application also with a bit of the cognitive load part, where 4 subjects, actually 5 subjects, were sitting in different computers across the company. So with many meters apart, and all the computers were recording their EEG while they were performing the same task, and we were trying to catch the engagement of all of them and rating it with a bar that would move up depending on how engaged they were during this process. And the experimental procedure at that time was doing the D2, which is an engaging, very similar to that what we will do today, where people have to select all the Ds with 2 points, which will engage them and make them be concentrated. Then they were shown a video, and then they were also ordered to try to play Tetris with 3 different kinds of speed: medium speed, a slow speed, and a fast speed. So we were trying to test how stressed they would be during this task and if they could remain concentrated with it. So this is the D2 which they were doing, and this is something that will be very similar to what we will do today. So they had to click and select every single item that had a D and 2 points. And during this time, we were measuring their EEGs. And this, for example, is a comparison between the results of the D2 versus the fixation cross, where we could positively see the engagement of the subjects arising when they were performing the D2 task versus the less or no engagement while they were in the resting task. On the Tetris task, the results were a bit different, but that was expected because we were trying to see how their engagement would, for example, increase with the different speeds of the game. So the pieces would fall faster and faster. And you can see that the engagement on the low was not that big, on the slow, sorry, it was not that big because they had enough time to decide their next steps. Resting, very low engagement, obviously. And then you see that when the Tetris becomes very, very fast, their engagement just rises. So very, very good example of what kind of applications you can do with this system. And I can show you a video of how it looked like last year. So you will see some familiar faces here. So Angela was having a look at her own PC, collecting all the data. Then we can see, for example, MJ, who will be also our user. Thank you so much, MJ. Was looking at the screen, performing the tasks. We also had Michi, who will also be here today. And our other subjects were Ali. So you can see different offices in g.tec, different desks. They were many, many meters far apart, but they were all connected into our network. So we were able to receive the data in real time and process it and get some results out of it. So they had a resting state task, then they were asked to perform this D2 task requiring concentration. They had to click all the D2s. We were trying to detect it. We can see them having a look. And then they had to also have a relaxation task by looking at the cross. And then you could see how engaged they are. So we can see that Ali was across the whole, so the subject on the right side was across the whole time very, very engaged. We can see Sebastian, MJ, and Michi trying their best to be engaged. You can see high engagement from Sebastian. Michi is trying to reach the top. So it was a very nice experiment. So if you followed last year's edition, it was very, very nice to see this presentation where people were able to detect the cognitive load from different PCs while using the unicorn in that sense. So for example, this is an example of the Tetris, which had medium speed, but once it got very, very fast, you saw how nervous all the subjects got, and that affected their concentration and the levels. So this is our experiment for today. We will have this time two main differences from last year's. In one side, we will not be recording from different rooms, so we will be doing a similar setup that you have seen with the P300. Everyone will be sitting in the same room, which is this one that I'm here right now. We will have 4 subjects, Maxime, Tamara, Vashali, Tina, connected to a G-high amp. So everyone is wearing a 8-channel cap connected to 164 active box connected to a high amp. So this high amp will be receiving 4 different subjects. And then to complicate everything, we will also be using the 2 subjects with 2 8 channels Nautilus, so that you can see also the potential of how Simulink will allow us to do this kind of very complex recordings. So Simulink will then capture all the EEG data, process the data. We will have a paradigm, which I will show you next, running on Unity. This everyone except MJ will sit in the front of the projector. MJ will have the honor to be sitting in front of the screen next to me, actually clicking all the items so that you can see how the paradigm is working. So everyone is using the 8-channel montage, mostly on the occipital, because then we can detect much better also the alpha activity when they are resting versus their cognitive load when they are performing the tasks, and we will be able to discern how engaged everyone is. So this is the paradigm. I can also then show you how it is running. So they will be having two main tasks. One is basically just relaxing, not doing anything, not thinking about it, where they will just have to stare at the fixation cross in the middle and just relaxing a bit. And then they have to do the cognitive load tasks, which this time is a bit different. We just made it more complicated for them. So they will have to look at three really small points, and they have to click it through. They will have 15 seconds per line. So we have here 12 lines, and you will have to complete this row task during 15 seconds. Otherwise, the bar will just block and you will not be able to click it. In the same sense, every time that you just fail and do not find the item that you're supposed to find, it will be marked as red. So you will be able to see if they are failing a lot. So that will be very, very entertaining too. And this is what we will be expecting from the feedback in real time. So on the scope, as you can see on the left side, we'll be able to see in real time if they are being able to be engaged during the D2 task or on the resting state with low engagement. So you can see, for example, on the pre-recorded data that we had on the experiment that we did in the past, you can see that the values are on the positive values. You can see from 0 microvolts to 10 microvolts. This means engagement, as you can see on the graphic on the left. And on the resting state task, you will see that engagement will be low. Also on negative numbers, 0 to minus 10 microvolts. And that's it from my slides. What I will show you is also, I will have to stop, change the screen. Let me change the screen for a second, and I will just exemplify the paradigm. So we created this paradigm on Unity. So this is another way that you have as an opportunity to create your own paradigms. It's pretty simple. You just need to press start, and you will be able to start the paradigm. The paradigm will be sending in real time trigger values through LSL to the network. And if you have, for example, a Simulink model which is reading and receiving LSL values, you will be able to see the triggers and then have it recorded in real time with the data. So this is very simple. This is what I will tell the subjects who are looking at me, or really looking forward to perform the task. Let me just remove my own face from the screen. They will have to select the items, as you can see, with the 3 dots. So this bar is already too late. It got blocked. So I will try to select more and more. So you can see you have the pressure of the time on the top. And right now I cannot click it. And when I go to the next one, you will see all the other items that I have failed. And this will repeat for around 2.5 minutes. That's how long this task takes, because we're having the different bars popping up. So MJ will be sitting on my screen. He will having access to the mouse and be clicking. All the other people, because typically they would have each one their own screen, but today, because of the spring school, I want to transmit so that everybody can see. They'll be looking at the projector and trying to find every single one of the three dots without clicking. So you will look at it and you're like, oh, okay, I found this one. Oh, I found this one. There's another one here. Obviously not talking. But you will have to be super engaged and be able to select every single one until the bar goes to the end. Exactly. And that's basically it. I will now stop the paradigm and I will stop the share screen and I will change my video camera to the other one where we will be able, oh, that's too blurry. Okay. Where we will be able to see everyone and I will tell them to take a seat. Can you please come to your places? MJ here, everyone sits on that direction. Exactly. So let me have a look here. So this is the setup. So we'll have the subjects sitting in front of the projector. So we can see the projector here. They will have the paradigm coming there. So I can start the paradigm again so that you can see how it will look like. So let me get the zoom to this screen and I can see. So I can start the paradigm now so that you can have a look what they will be able to see. So MJ, can you click it just for them to see at home what will happen? So you can see MJ trying to detect all the 3 pointers, sorry. And everyone, as you can see, he's very, very attentive and looking neatly at the screen. And we will now start with the process of gelling everyone. I will start with MJ because time is short and we will have to quickly do the setup. Just a second. Obviously, I've let the G.tec tools on the other side of the table. So I will be putting the cap into MJ's head. I hope you have seen my lecture on Monday, so you know exactly how to mount the EEG cap correctly. I am checking the CZ position. So I'm using G.Nautilus Ladybird and with 8 channels. I will be starting gelling him right now. I will start with the reference, which is on the other side of the head, but you can see it here. And I can put it on the front. And then I will just simply put on the ground on the FZ, on the CZ, on the P3, on the PZ, and on the P4, on the P07, on the OZ, which is channel number 8, and on the P08. We will then be able to go to Simulink afterwards and check if the data is fine. I will ask MJ to also stand up and help me gelling all these beautiful people here waiting for me. So what we will do, Mishi will have the Nautilus, which MJ will put on his head. And let me just pass my headset to the other side. Always complicated things. And we have then, why shall we here, having an 8th channel into our head. So if you can help me just holding the frontal part. Let me just see if people can see exactly. So very good. To be super precise, you should use always tape to check the differences of the skulls. This is very good. I will just measure ASEAN and Inion, and the CZ should be a bit more to the front. And we will just plug it in. I need to close it together. How are you? Are you comfortable? How are you feeling? Nervous? Very good. Okay, great. So we will do the gelling. Of the ground. Gel number 1. Gel number 2. Up. MJ, can you give me a towel, please? Let me tear it. Thank you. So can you feel the gel? Yeah. You will go home with a very, very jelly head. But it's necessary for good EEG signal. Can you just turn the head some help me? Thank you. And that should be fine. It's good. And the reference is there. Oh, good. The manga, how are you doing? So far, so good. Can you just lift up? Yeah, exactly. Stop. Can you just put your hair a bit to the back? Yeah, exactly behind the ears. And hold it from the front. Exactly. So yeah, to perform the montage, I used S caps for most of the subjects. And wait a second, I have placed it on the opposite side. Can you hold it again? So you can see taking care of 6 different subjects may take some time. A second. Let's measure your ASEAN and the Inion. That should be fine. Okay. MJ, for the high amp, we're using passive on the neck. You have the clips there. On the neck, sorry, on the mustard. Good. So I will start by gelling the caps. So to convince everyone, I told that they will get drinks. So they are very looking forward for the end of the presentation. Otherwise, I would be here standing alone, no hyperscanning for you guys. But I'm glad everyone accepted. So let me, exactly. This is not, this one is for you, this is for you. So actually, no, this is, can you give me a sticker on the back? This is, yeah, exactly, but and it's just on the cap. Can you sticker? Yeah, exactly. So I'm using the ground behind the mastoid. So I'll just lift up, remove the sticker. Okay. So second subject, guess we will. Can you do it with Maxime? Because then I can show people a bit more of our application. So everyone is almost done. So just one subject is missing. And the paradigm is at the end there. But we will be then seeing a bit better how the EEG is looking like on the screen. I will remove now this camera, pass to my own camera, because hyperscanning with so many devices requires a lot of USB ports. So I'll have to remove the webcam and add one of the Nautilus into the PC. And I will be able to show you how we are running with the Simulink model. So there we go. So the Simulink model, I hope everyone can see. I just need to remove my bars there so that you can see. So this model is performing the following. So we have, as you can see, the block with the different amplifiers. They are acquiring the G high amp, which you can see on the serial number on the top, 2016-0204. We have two G Nautilus. Both of them have 8 channels. We have 32 channels because we're acquiring 4 different subjects with 8 channels each. And we have an LSL receive marker coming into the model itself. I have a visualization part where I am applying a 50 Hertz notch filter and a band pass filter, 0, 1 to 30 Hertz. And we are going into the processing pipeline where you can see that because the two amplifiers have 2 different sampling rates, you will have the high amp ones running at 256 Hertz and the G Nautilus, the 2 G Nautilus, at 250 Hertz. But this is okay because we are recording the models and we are taking, so as you can see, as you know, MATLAB is always taking a channel with the time. So you'll be able to have both amplifiers in synchrony. And here we are, as you can see, a very complex modelings that we have done for this experiment. We are separating the different bands of the different subjects. So we have 4 to 8 Hertz, 6 to 10 Hertz, and 8 to 12 Hertz for the 4 different subjects. Therefore, you have Max putting out all the different data from the different subjects, and also the same happening for the 2 subjects with the G Nautilus. We will be then calculating and recording the features on MATLAB, which then we can use as a classifier to then have the real-time feedback, as I mentioned to you. I can go to the other screen on the behind the here mastoid. This will be the ground. Thank you. Exactly. So I can show you, for example, on the other screen when we are running. So everything is fine. I'll have to restart the paradigm. And once we restart the paradigm, we'll be basically ready to go. The paradigm open is very important because the model will be searching if there is a LSL port open in the network. So we will be able to see the paradigm screen on that window. So the paradigm needs to be opened. And we will be then trying to run all the models, and we'll be seeing if the EEG is going good. So the model is opening all the Nautilus and starting the acquisition. MJ can already come and sit next to me. Let's have a look. So this is a good thing about the g.Nautilus is that you can have one of the one of the subjects actually helping you preparing all the other ones. Yes, so I can actually I'm sharing the screen so I can see the EEG data acquisition, which is a bit noisy. Let's have a look. So we'll have a bit of noise. So you can see the data acquisition happening in real time for all the users. We can there with different locations. So we had one user moving a lot. It was Vaishali. So you can see when she moved, you would not be able to see much of the channels. So we can have a look separately on or with everything. So can everybody bite? Let's see if we see bites there. Can see some bites there. This was Michi, MJ. Can you bite? Okay, can see the bites there. We can have a look at all the other ones. There is power line on the channel 1. Let me see if we can fix. I think we need to power the ground. Let me just have a look and fix it for you. Or can you do it? Can you just have a look if the ground is connected? Yes, because would be great if I had wireless ones, but yeah. In any case, this looking pretty fine now. So I can have a look at the data. Okay. Close the eyes. That's good. Can you blink? I can see the blinks there. Okay, that's fine. So we can start the paradigm. So MJ, if you can come here. So I'll put the camera to the star of today. And we'll be able to have a look. So everybody understood the task. So we will have to find the 3 spots. I will just remove this part here. The 3 dots, concentrate. If there is a cross, just try to relax and don't do anything. We will do the first session just by running the model, and then we will have a file which will create a classifier, and then we can do the feedback. So we will start. The mouse is yours. So relaxation right now. So Christoph is filming me. I will be appearing on LinkedIn, but this is a very nice experiment for you to see how many people you can actually connect at the same time and do a very nice paradigm with cognitive load. We have, as I mentioned, 4 users hooked on a high amp and 2 with g.Nautilus. Everything is running smoothly on Simulink. So if you guys at home are looking at the cross, you will be asked to perform also the tasks, and being relaxed, this will serve as almost a meditation task for you all. And soon there will be a relax on the screen, which is a midterm task, and now MJ will have to perform the cognitive task, and we are recording. Everyone is trying to find their correct 3 dots. If MJ will fail, it will become red. As I'm talking, I'm putting extra pressure, which is not part of the paradigm. So he was not unable to finish the first row. Let's see how he performs in the second row. I was a bit mean and decreased the normal speed for the sake of the presentation and for increasing how nervous they get when they're trying to find all the three dots. So the task of D2 would take, as I mentioned, 2.5 minutes. The relaxation frequency cross around 1 minute. So in total around 15 minutes for the recording. And then we will be able to have already a feedback loop in real time, where we'll be able to see if everyone is able to concentrate or not. For the classifier, we are separating the users on purpose, because when we are doing a median, we can actually can actually have a higher accuracy rate. So if a user is, for example, being pretty bad and not able to concentrate, then this will not highly affect the results of all the other subjects, which is what we actually want. But in principle, you could use the classifier as you wish. You can classify it one by one, merge the data together. You can do an averaging, you can do a median of the results. It's highly dependent on what is the outcomes that you want to do. The most important part here is really to realize how such a very complex setup like this one was able to be used in a couple of minutes. I guess I took around 10 minutes to prepare everyone with the help of MJ, who is now listening to me and being distracted. Don't laugh. So yeah, this is just really to show you how neat and how clean our Simulink interface looks. You can select different amplifiers. You can use the paradigm presenter, for example, for other kinds of applications. This one, because we needed to have someone clicking, we did it on Unity with LSL trigger transmission. So it will always depend. Paradigm presenter can be used from within the Simulink. So you have that big pro, and then you can use this as a tool for your own applications. I will not talk too much right now. So they need to relax, not think about anything. And then there will be the second round of D2. Obviously, this setup is not ideal because I'm talking and distracting them, but this is what spring school is like. So this fixation cross relaxation task is almost over. And soon we'll start the second task with the D2. Exactly. MJ is trying to speed up. Everyone is trying to detect their spots. So yeah, this is a very good application. So I guess you get a very nice overview of how these applications can work and what is required. In terms of Simulink, things are already ready to go. So we have all the available blocks for you. You can also classify, record the data, use PS Analyze for the classification of the recorded data with the nice results. Then you can also get the statistic analysis of the classification of your data. So our um, our toolboxes are very useful for these kinds of applications. And I'm actually pretty amazed by how seamless integration this is, because getting two amplifiers is already complicated. Most of the times you will need a trigger cable that is sending hardware triggers directly to the digital input port of the amplifiers. But with Simulink, this is not necessary anymore. You're recording the data and you're having a really nice acquisition for most applications, obviously. There are always applications which you will want to make sure that there are no jitter nor anything. So a trigger cable is always a very good solution. But if you are not caring too much about the precision of the start and the end of a task, these kinds of applications are pretty neat. So you can use this for EEG, for FNAs, for whatever you want to use. We're almost over. I hope you guys found more easy spots than MJ did. But it's pretty quick, yeah. All good. We're in the last bar, and then we should have the end of the classification round, which we have still a bit of time to run the feedback. So the end. Congratulations, everyone. You can relax finally. I can hear how desperate they were, especially Tina, because she cannot concentrate. And I will stop the model now. And we will have the data recorded there. I am just processing with our script. So everything went as fine. And I will be just uploading. Should give me just a second to upload the classifier and run the script. And then on the model, so you can see on the model here, you get on the diagnostic a very nice impression of the system trying to open and starting the acquisition of everything. And we are running with the classification. I will just actually let me comment in. And then this will be the scope for the visualization. We are recording a file called cognitive load, which then you could use, for example, for offline analysis. We're having a block with all the LDA classification coming by now, because we already were able to run it through. And I will restart now the paradigm, and we will be able to see the things happening in real time. Let me just open again the paradigm. It's a very nice view, I guess, from Southern European country. And now you have Unity. Yeah. And we can start again the acquisition on the other screen. Which is trying to open. So already opened the amplifiers and starting to acquire first Nautilus and then the second Nautilus, and then it will start to run. It's now receiving the data. And we can have an overview of the score in real time. And I will be starting the paradigm. I will let them run a bit. again, so everyone starts again, and then after some time I will share the screen. I will change the screen so that you can see the feedback in real time. Because Unity's internal core programming, if you change the screen, you will stop the paradigm. So I will just let the paradigm run, and then we'll have a look in real time what is going on our subject's head with the real-time feedback. So everyone is relaxed right now. And after that, we will do the D2, and hopefully we will be seeing changes on the features, on the classified features, on the scope. So you can see again the rest. And the D2 coming up. MJ trying his best. Okay. I will ask MJ to give me the mouse so that the other ones can continue, and he can also continue to do the tasks. And then we can see here because the task was stopped, you can see the cognitive part just lowering. So it's hard because you need to have it activated for them to be concentrated. I'll stop again and see the reaction. So you can see while they were doing the cognitive task, the results were much better. And now that we stopped, it's getting lower and lower. So it really fits to what they are trying to do. I'll ask MJ to restart again. Then we see if there is a raise on the feedback in real time. Everyone, give me again. Sorry, I have to always stop. And then you can see now the task started, the cognitive load increased. I stopped it, the cognitive load is decreasing. So very good sign, very good sign. Yeah, I think we are almost over in time. Yeah, that would be my presentation. I hope you had the chance to have a look at all our features. Thank you so much, MJ, for doing such a wonderful job in clicking. And I hope you have a lot of questions for us. Thank you so much. This was my presentation about hyperscanning. So,
thank you very much, Frankie, for the nice presentation. We have also a couple of questions. Manuel is asking, is g.tec using LSL to synchronize the different EEG streams?
The EEG itself, we are synchronizing with our block. So we have a multi-device block on Simulink, which is actually doing all the acquisition in real time. The LSL is just receiving all the triggers coming from the paradigm that in this time we created. We could have used for another application, the paradigm presenter, and that would be within Simulink. But in this case, because it was on Unity, we decided to go through LSL and receive the trigger from LSL.
So normally we are using LSL for lower bandwidth. So if the signals are pretty slow and if something is really fast, then we do it directly with memory share. Ivan is asking, do you know if hyperscanning has been used for astronauts on ISS?
Personally, I actually don't know, but that would be a very interesting project for sure.
This is also what Ivan is saying, and he even suggests to do it on the moon.
We can try it next spring school, Christoph.
This would be very nice because then we can sell a couple of Heims to do a moon expedition. And he would also be interested to study microgravity. This is something that we actually do in October. So our equipment is used in a zero-G flight with an Airbus. Actually, tomorrow is a lecture about that from Schillings. Then Manuel is saying, could be interesting to apply hyperscanning to understand empathy.
This is something that you can actually find some papers. So I know a paper that measures the synchrony and empathy between, for example, mother and a daughter. And I've already seen also other kinds of paper that are actually measuring empathy between people and situations by showing videos, for example.
And Carlos is asking, how did you actually quantify engagement?
So we are looking at the different bands, measuring alpha and theta activity and the changes of the modulation that are happening in real time. So we are literally comparing an activity state, a cognitive state during the realization of the task of finding the 3 dots in this case, or the D2, and then comparing to the resting state, where we will see then more alpha activity on the resting state compared to the cognitive load task. And like that, we can do a very nice comparison between the 2 applications.
And you see how easy it is. Frankie mounted now 6 persons for the real-time experiment, just doing the lecture within 1 hour, and was able to conduct the experiment.
And with
this is
Zoom.
exactly how it should be. So thank you very much.
Welcome, Christopher.